conference. Let me first introduce myself. My name is Acteon, and I am the CEO and founder of the company Sopro. I have a scientific background with a PhD in digital signal processing. So the company Sopro is located in the southern part of France, nearby Marseille, and it is devoted to provide imaging solution to both the dental market and the endoscopy market. Our portfolio in the dental industry includes intraoral cameras, caries detection units, for both of which, by the way, we are #1 worldwide, together with a digital radiology system, including sensors and scanners, and of course imaging software. For the endoscopy market, our portfolio includes cameras again, with a wide range of cameras, including 3-chip, single-chip, autoclavable one, CMOS, HD. Light sources, insufflators, irrigation system, as well as endoscopes. A wide range of endoscope again, for urology, laparoscopy, gynecology, ENT surgery, spine surgery. And together with those scopes, we also provide surgical instruments. This family of products is not made in La Ciotat, but in our manufacturing plant in Germany, in the city of Tuttlingen. Sopro joined the Acteon group in 2001, and since that day, we paid a very close attention to the fluorescence, both on soft and hard tissues. And recently, 2 major products for our company came out on the market, but I will come back later on those 2 products at the end of this presentation. So, fluorescence, how does it work? Fluorescence is the capability for some substances to restore photons after receiving an excitation. Usually the wavelength of the light emitted is different from the exciting light. Let's say the light color are different from the incoming and outgoing. This phenomenon has been known since antiquity, but it has been only described scientifically in the 19th century. Fluorescence can be split in 2 major areas. The first one, induced fluorescence. In this case, the fluorescence molecule is added into the substance you want to analyze. In the case of autofluorescence, the fluorescence molecule is part of the material that you are analyzing. There are several applications that you know for sure directly issue from fluorescence. Some in the industrial field, some in the medical application. I would name for the industrial industry the neon lamp, of course, since Bechdel and Edison work in the 19th century. Coming back to the digital industry, dental industry, sorry. Digital sensors, which is a component which includes thin layers of a component named scintillator, which has the capability to emit white light when it is heated by X-ray. We can also name the white LED, which are actually blue LED, and the blue light hitting a yellow phosphor coated inside of the brain. Now, in the medical field, the most famous one is most probably the DNA labeling. The DAP molecule is, of course, fluorescent, and has the capability to bound itself to DNA. So this technique is mostly used for detecting and quantifying the DNA. It's also heavily used for studies of cellular death and Alzheimer's disease. Cystoscopy, which is the examination of the gallbladder, used in conjunction with X6, which is a fluorescence molecule which bound itself to neoplastic cells. This will allow you to detect cancer. And closer to the dental industry, also oral cancer detection. In this case, we are back to autofluorescence. We don't need added molecule. In this case, this is the absence of fluorescence, which means higher level of metabolic activity. That's a cancer. I will now go on with describing very shortly the R&D study we have been so far has been conducting during the last 10 years with different laboratory, university, and research centers. So from 2001 to 2004, SOPO has been collaborating with the Laboratory of Chemistry and Physics of Biomolecular in the University of Pierre-Marie Curie in Paris. The aim of those studies has been to get a fluorescence mapping of different tissue, both soft and hard tissue. In the case of the tooth, we can see the different layers inside of the tooth, dentin in blue, and then you can see the green dentino-enamel junction, and together with the enamel in blue, and obviously a wear or a cavity in red. In the case of the soft tissue, this difference between the tumor and the sound tissue is quite obvious. Based on those studies, SOPO has been able to fill an international patent named Device for the Detection and Characterization of Biological Tissue. The product which is described inside of this patent provides in real time the fluorescence of the tooth superimposed on its anatomical structure. This patent is really the cornerstone of all our new and innovative products that have been launched recently. Then, since between 2004 and 2006, we have been collaborating with both Bordeaux CNRS and Dental University in Strasbourg. The aim of those studies was to detect early stages lesion inside of the tooth. Since this time, and still today, SOPRO investment in the scientific community of dealing with fluorescence has never stopped. We have been partnering with prestigious universities all around the world, and all of this came out with the first international conference on fluorescence-based diagnostic of oral disease. This congress took place in Montpellier last year in September. And I would like to name just a few of the conference people who attended this conference in September. First, Professor Cuisinier of Montpellier University. Professor Tasri, who is with us, I saw him, from University of Marseille. Professor Reichmann from UCSF in San Francisco. Professor Hotsuki from Tokyo Medical and Dental University in Tokyo, of course, and Professor Manton from Melbourne. Let me now briefly introduce you the two major products which came out from those 10 years of studies in fluorescence. The first one is named SOPROLIFE and was introduced during the IDS 2009, so exactly 4 years ago. It immediately made a huge success, especially in the US. This product is by far #1 in the caries detection group of products. Basically, it's an intraoral camera with 3 different modes or 3 different positions. In diagnostic, the product will help the dentist to make a quick screening of the mouth to detect caries, even if they are on a very early stage. The treatment mode will help the dentist while excavating the cavity. And the daylight mode is the intraoral camera position. So here are some pictures of what can be provided with SOPROLIFE. You see the same tooth under daylight condition and in the diagnostic mode. We clearly see, in this case, red signal, dark red signal, which is significant from demineralization in the dental groove. On the right side of the picture, you can see the treatment mode. So this is the beginning of the treatment. Let's say we open the cavity, you see a dark red signal for the infected dentin. And this is at the end of the preparation. No more dark signals, so no more infected dentin. So this was for SoproLife, which was introduced 4 years ago. And SoproCare, this product has been launched in Vienna, June last year, during the European Congress. And by the way, we just learned yesterday that we've got the Food and Drug Administration in US approval, so we can now release the product in US also. In this case, we use the same pattern, the same technology, same know-how, but we target both soft and hard tissue for the tooth. There again, we have 3 major modes. Too quick. Yes. Daylight again. So once again, this is working as a standard intraoral camera. Standard, but with a high level of resolution and quality. Perio. In this case, SoproCare will help you to detect plaque and gingival inflammation. And the cario mode, which helps the dentist to detect caries. Here are the different pictures you can get from this product. The same tooth under daylight condition and under the perio mode. In this case, the dental plaque is hardly visible, and when you switch to perio, you see the yellow-orange glowing area, which means dental plaque. And you can also see the thin cervical inflammation of the gingiva due to the plaque. Now you don't see anymore. On the right side, you can see the same tooth, both in daylight condition and within the cario mode. Obviously, the red signal that you can see in the dental groove means you are facing a stage 1 carie. Different studies, clinical studies and scientific studies, have been initiating on this product recently. Most of them are still running, and I will now let Professor Grimm introduce what he has been doing with this product during the last weeks and months. Thank you.